In this video, I'll show you two examples on how to solve any percent concentration problem. To solve percent concentration problems, you'll need to know this formula, where percent concentration is equal to the amount of ingredient A over the total amount of mixture times 100. The first question reads, a certain fuel mixture contains 18.9 liters of alcohol and 84.7 liters of gasoline. So this mixture contains both alcohol and gasoline. Find the percentage of gasoline in the mixture. So in our case, our amount of ingredient A will be 84.7 liters, which is representative of the gasoline. So we'll write down 84.7 divided by the total, and in our case, it's 18.9 plus 84.7 times 100. Let's use our calculator to evaluate this. 84.7 divided by the sum of these two, 18.9 plus 84.7, multiplied by 100, and that should give us 81.75. So let's write this down to 3 decimal places, because this has 3 significant figures and so does this, so our final answer should also have 3 significant figures. So let's write down 81.75. Now of course we'll have to get rid of this 5 because we only have 3 significant figures. And since this number, the last retained number, is odd and the number after it is 5, this will be rounded up to 81.8. And that represents the percentage of gasoline in this mixture. In question 2, they ask, how many liters of gasoline are there in 155 gallons of a methanol gasoline blend that is 10% methanol by volume? So here we have a mixture that is 155 gallons and 10% of it is methanol. So to find out how much methanol there is, I will take 155 and multiply it by 0.10. If I multiply 155 by 0.10, I should end up with 15.5 gallons. So there are 15.5 gallons of methanol and the rest is gasoline. So 155 subtracted from 15.5 gives us 139.5 gallons. They're asking how many liters of gasoline. They don't want gallons. So what we have to do next is convert 139.5 into liters. And to do that, we'll use this conversion ratio. We'll take 139.5 gallons and we'll multiply it by 1 liter over 3.78541. Now in regards to significant figures, this is an exact value, so we're not going to take that into account when finding the correct number of significant figures. Let's do the multiplication here. 139.5 times 1 divided by this number, 3.78541, and we end up with 36.85. 36.85 liters of gas. Now to be mindful of the amount of significant figures, this has 4 currently, and the number that we're supposed to remove is this 5, but because the last retained digit is even, we don't round up. We just leave it as 36.5 liters. And so there you have it. That is how to solve any percent concentration problem.